So welcome back. I started a file. I got right up to the same spot, and I just want to show you how to get back into your work if you do happen to have to do a force close with Control-Alt-Delete. So I'm opening up that same file. This is the inspection file that we want to open. And this particular file that I saved has the alignment completed and nothing else. And another thing I should mention here is that you want to save and save often. And if you want, you can also save under a new name. So one thing that I'm in the habit of doing, I'll come up periodically and do a save as, and I will come in and put some sort of something at the end. I like to use WIP for a work in progress. And then I'll put a dash and a number, and that just shows me my checkpoint. So you know what? I'll do WIP-1 for right now. And after I do a couple more steps, I'll do WIP-2, etc., etc. So all it does is add a little bit of extra information on your computer. If you don't want it there, go delete it afterwards. So to obviously this closed down my planner window, and this particular file does not have those circles yet. So I'll go back and put the same circles in there. I'll go define circle on cylinder. And notice that my simulation is not open now. You can do this with simulation on or off. It really doesn't matter. If you want a feedback loop, if you want to be able to see what you're doing, maybe you want to have that simulation window open. But for right now, I'm just clicking on those three circles, and then I'll come back in and I'll double click on circle 1. I'll come up to strategy, see points are filtered on already, and then I'll click 1, 2, 3. Notice it gives me this pop-up window. It's called Calypso Default Report. You can always close this down. This is just showing you what that feature measures at. It shows you the X, Y, Z, the diameter, etc. So it's not information that we need to know, so we'll just close it. So I have 3 points so far, and the 4th point will be over there. Let's see if we can just move this out of the way so that when it does pop up, whoops, when it does pop up, at least it's not in our view. Those windows are my biggest pet peeve with Calypso. It has a lot more windows going on than it needs. So hit OK there. And while we're here, we want to output our X, Y, and diameter for the circle. And how do I know that? Well, our X is going to be balloon number 2. Our Y is going to be balloon number, oh, looks like I missed that one. I'll have to go back in there and add that in. I don't know how I missed that. And I missed another one over here. It's amazing the things that you miss when you try to cut corners. All right, so we'll say OK. Then we'll come into circle 2. We'll do our strategy. Again, it's already filtered to points. We'll go 1, 2, 3, and 4, and say OK. Again, for this one, we want to do X, Y, and D, and apparently I missed that on the print, so by the time I update the print, you will be doing X, Y, and D for that circle. And then we'll come into the 3rd circle, and under strategy, we'll do the same thing. Do 1, 2, 3, and 4 points, and say OK. Again, X, Y, and D on those. And then we'll say OK. All right, now one last thing that we are going to do in each of these circles while we're in there, we will output our depth. And I didn't forget this one. That's one thing I didn't forget. 310 thousandths is going to be our depth. So with that circle type feature, we don't have any way of measuring the depth of the flat bottom. Now, if this were a drilled hole, we wouldn't be able to do this, but these do happen to be flat bottom holes. It's great for learning how to program CMMs. We'll come over here and we'll go define points. And with this, we'll simply click right on the bottom of that first hole and say OK. We'll click right at the bottom of that second hole. Oh, and you know what I should have done on the first one? I should have clicked that Z and said OK. We can always go back and update it later. And then we'll click on the bottom of that 3rd hole. We'll click on Z here. And by the way, when I'm clicking on these buttons, it says it right here. It says tolerance 4, and then it gives you a default nominal tolerance pulled off the CAD model and a default upper and lower tolerance. And mine is set to 3 thousandths and 9 tenths. That's just the default in the software. You can actually customize these to be plus or minus 5. I like to leave them at 3 thou and 9 tenths. So that way when I look at my dimension report, it sticks out like a sore thumb. If I see that magical number of 3 thousandths and 9 tenths, it means I didn't update it. And I certainly could update them now, but it's not a workflow that I like to use. I find it to be too distracting if we try to do too many details at once. This software is great for going back and updating things later. For instance, for point 2, I realized that I forgot the Z. I'll just open it up, click on the Z, and click OK. It pulled my nominal and tolerance information off the model. And another thing I noticed, we're going to measure circle 1, then circle 2, then circle 3, and I'm looking at them on the graphics screen when I click on them. That's 1, 2, and then 3. And that's not terribly inefficient. But then when we go back to point 2, point 3, and point 4, we make that same relatively large travel distance again. Well, if we want to change the order that these are in, we simply click and drag them into position. Right? So our workflow is get all of the information off the model first, and then make the path efficient later. Now also, when we started clicking on these features, these are all our measured features here. These here are your alignment. Right? These first 3 are your alignment, so there are no measured features with this. After we created these features, we didn't see anything in the Characteristics tab. But now when we switch over to the Characteristics tab, we see a whole bunch of characteristics. Why? Because we created characteristics directly off each feature. So this point right here has a Z characteristic. That's the Z depth for point number 2, and when we look over here, we should find that in here somewhere. There's the Z value for point number 2. Now notice that this characteristic list does not go in order of the balloons. We can move the order of this afterwards as well, simply by dragging things around, and that'll make it much easier to tie a balloon on the print to a balloon number in your dimension report. We'll worry about all that later. For right now, let's make sure that our programming actually works. So we'll open up Planner and we'll go to Measurement Plan Simulation. And by the way, one reason that I believe caused my computer to freeze earlier in this video, I had the pause button on in Measurement Plan Simulation, and I was trying to touch points off of the model directly when I had the simulation window open. So I have noticed some system instability when you try to do that. That's why the second time I came at it, I just closed the simulation window before I started taking points. That way I won't mess myself up here with this. So if you have that problem, just it's one thing you can look out for. Make sure either the play button is on before you take points, or just close the simulation window. Ultimately, you're always going to open the simulation window before you simulate your part anyway. Right? So you don't really need to see the simulation while you're probing points, unless you have a good reason for doing so. All right, so we have pause button on in our simulation. We are in the Features tab. We'll come to the Run window. We'll clear existing results. Default PyWeb is good. For this, we will do our named alignment. All characteristics will go from feature list, clearance plane. We'll do step mode here as a default, even though it will be overridden in the simulation. We'll do 40 millimeters a second, and we'll say start. Here, we'll say switch to CNC run. If we were in person, we would say continue, right? So switch to CNC run. We can X out of this. If it asks you to save changes, say yes. And then we will step through our program. Right now for the alignment, I already know what's going to happen, so I will speed this up a little bit. Right, so there we're touching the top, 3 points on the top, 2 points on the front, 1 point on the left side. And now that we're to the section of the program that we care about, we will slow it down a little bit, and we see that we're taking 1, 2, 3, 4 points on the circle, moving to our clearance plane, 1 point at the bottom of that first circle. 1, 2, 3, 4 points on the second circle, and 1 point at the bottom. And another thing I'm looking for here, I'm making sure that this is safely moving from feature to feature. And in later videos, we'll notice that there is a collision detection feature that can make this much easier when you're doing more complex programs. Now, it was subtle, and I didn't mention it, but in the background here, these characteristics were actually being populated as we acquired more information off of the CAD model. So these characteristics are what generate the dimension report. And down here in my tray, see that I have my Calypso monitor. You can always hit the settings here, uncheck all 3 of these, or 4 of these rather. Say do not record and X out of it. That records your cycle time for each run. It's helpful when you're running production, not helpful for what we're doing. Also, this Calypso report that kept popping up earlier, that is a window that you do not need. In fact, any window that shows up in Calypso, that is going to show up in your Calypso icon down here, can be closed out of, except for simulation and the overall window. All right, so don't be afraid to close out the windows. I assure you they will pop back up if you need them. In fact, it ends up being pretty annoying once you get used to the software. All right, so the last thing that we need to do is check our report. So for whatever reason, the first time this runs, it does not show you your report. And certainly we could run it again, or what's easier, we could just hit View and Multiple Report. So that reruns all of the information in the background and dumps it into your report. Now, of course, when we're looking at our dimension report here, I did not update any of the nominal values, and I didn't update any of the tolerances. And these are not necessarily in the same order as the blueprint. So we talked about how to do this in class. My next move would be to, let's see if I can shrink this down a little bit. My next move would be to close out of this report because I know it's incorrect. I'm not even worried about these features that are quote unquote out of tolerance because I didn't update the tolerances yet. I'm not going to walk through everything in this tutorial here because you did see this in class, but we'll walk through a few. So the first two balloons are balloon number 1 is the Y dimension for hole number 3, and balloon 2 is the X dimension for holes number 1 and 3. All right, so I'll just do hole number 3. Hole number 3 is Y, comma, X, comma, diameter, comma, Z. All right, so let's go find hole 3. Well, hole 3 is actually called circle 3 in the program. So we'll go find Y value, circle 3, and we will simply drag that up to the top. That wants to be our top item. Then we'll go find the X value, circle 3. We'll click and drag it up to the top. And I didn't mention it, but I am in the characteristics menu when I'm doing this, right? The things we care about, the things that go on the blueprint, they are in the characteristics menu. So if you care about it, it's in characteristics. All right, the other thing we need is diameter for circle 3. All right, so Y value, X value, diameter, and then the last thing we need is the depth of whatever circle 3 is. So point number 4, I'm clicking on the features menu now, and I'm looking at the point. And I'm using the graphic screen to tell me if I'm correct. And I am correct in this case. Point number 4, Z value, is going to be balloon number 5 on the blueprint right here. So now I'm going to name these. The Y value is B1. So I'm going to say B1 for balloon 1. So it's going to be B1. So we will double click on this. We can rename it here. We'll say B1 underscore hole 3 dash Y. So you can name this whatever you want, but I recommend this strongly as a standard. Let's see, did it grab the correct nominal information? 2-inch 189. Yes, 2-inch 189. And if we had the entire print open, we would find that that is a 3-place decimal, and a 3-place decimal is, looking down in the title block, is going to be plus or minus 5 thousandths. So for whatever reason, the default in the software was not 5 thousandths. So we'll update that to 5 thousandths. All right, I'll copy all this information because now I'm going to go do the same thing on this. But now the X value for circle 3 is actually going to be B2, balloon 2. How do I know that? It's right here on the print. All right, hole 3, X. All right, we'll update our nominal information. Our nominal information should be 1-inch 512 plus or minus 5. You see the nominal came in slightly off. This CAD model was created. Okay, so it'll give me a little warning here if I change the nominal and it's not consistent with the model geometry. Do we want to change the nominal of the selected geometry feature? Say yes. That's just saying it doesn't match and you could be causing problems. In this case, I want to do that. Right, the CAD model was created with slightly different dimensions, 1-inch 5118, because it was created in metric originally. This is a German part, so it makes sense they would be using metric. All right, so let's get the balloon number for the diameter is balloon 4, so it should be B4 underscore circle 3 dash DIA. The nominal is 472 plus or minus 5. So B4 whole 3 dash Z. Nominal should be 475. We get that same message. We just say yes to this. Our upper tolerance is +5. Our lower tolerance is -5. Oh, I'm sorry. I named that Z. That should be diameter. I guess I can't talk and think at the same time. The nominal is also 472, not 475. All right. So we'll say OK here. And then for our Z value, 310, balloon number 5. So balloon 5, hole 3, Z stands for depth, and this nominal should be 310, not 315, and this should be plus or minus 5 thousandths. Say OK. Now again, we would do this for the entire list. We're going to go systematically. You find that if you have some things that are red, it's probably a case where your nominal information was not correct. Let's just go correct this one as an example. Yeah, our actual here is 289. It says 322 for whatever reason. Let's say that that was 290 thousandths plus or minus 5, just for ha-has. I don't know if that's what the print says, but let's just say that it is. Notice that that feature was red and it is now green. All right, after all that, we'll go View and Multiple Report, just to show you that these values have been updated. And looking at that report, you can see the updated feature names here are much easier to read. They are much easier to tie to the blueprint, and it's much easier to go systematically when you're verifying that each balloon was measured when you do your first article inspection, because now you simply go from top to bottom and just put a check mark next to each thing once you know the nominals and the tolerances are correct. So that is my standard operating procedure for when I quote-unquote prove out a CMM program. So for this assignment, you are going to save your inspection sheet, or I'm sorry, your dimension report. So View, Multiple Report. I don't know why I closed that. We're going to come in here to the Fetch Data. All right, we'll come into Downloads. And for this assignment, it's offline. So I'm just going to grab exactly the same name as the file itself. So that is the file, and then I'm going to put underscore dimension report at the end. And we don't have to do a run number or an index number here because we're not actually running it on the machine yet. This off tells me that it's offline program only. Right, so this is just a quick way that I can see if you have systematically verified that all of your nominals and tolerances are correct. The other thing you're going to save is your inspection report. So when you go to submit this to Blackboard, you'll come in here and you'll hit Browse My Computer, and you will submit your dimension report. You see it right here, and then you'll come into your folder. Calypso will automatically put it in a folder, and you will also grab your inspection sheet. Or, I'm sorry, your inspection file. Your inspection file is what drives the machine, and the dimension report is the dimension report that you got out of that. Right, so you will have two files before you hit submit. You'll have two files attached, and then you'll hit submit. So that's all I got for you today. I hope you enjoyed the video. I'll see you at the next one.